In this LLM-05 notebook, we'll be looking at some tools that will help us examine representation bias in our data, and also look at a few post-hoc tools that help us to calculate toxicity score and also generate explanation on model output. We'll also wrap up by looking at one example of latest research in generating model explanation known as contrastive explanation. As with other notebooks, we'll start out by setting up our classroom environment. So go ahead and run these 2 cells and pause the video to come back once you have set up the environment. Now that you are done with setting up your classroom environment, let's take a first look at the first tool that we'll be using to examine data bias, which is a tool called disaggregator developed by Hugging Face. So as the name implies, it attempts to disaggregate data so that we can actually try to examine the data in more granular detail, leveraging different modules focused on different topics. For example, we can use age, gender, religion, continent, and also pronoun disaggregation modules. For the purpose of demo, we'll be using Wikipedia bios as our data sets, and we'll also be using the pronoun module because all of 5 of them, the pronoun module takes the least amount of time to disaggregate the data, and you are welcome to try out other modules in your own time as well. We acknowledge that some content may be triggering and offensive, but we hope you understand because the models developed and used in this course are purely for demonstration and learning purposes only. If you do decide to try out the gender disaggregator in your own time, just know that you need to have the Spacey English Core Web Large model that we already pip installed in the first cell over here. And different modules will take varying time to disaggregate the data as well. So in this case, we're going to be using the pronoun disaggregator module, and we'll be using the Wikipedia biographies dataset. So you'll be seeing the first paragraph, which is the biography of the dataset, and then some other information about the Wikipedia bios. So for this aggregator to work, it needs to be able to invoke the .map function onto the data. So here we're using the Wikipedia bio dataset directly from Hugging Face dataset. When we run this cell over here, the .map function, or the API call, will attempt to group all of the Wikipedia bios into these categories: she, her, he, him, or datum. It's possible that it will label true for more than one of them. And in fact, let's take a look at the data frame itself. Upon closer inspection of the results of this aggregation, we realize that it doesn't do a very good job at determining datum because the model is not trained to distinguish datum pronoun. And it seems to classify mentions of any physical objects as datum. So as an example, we can either read from this markdown, or we can also look at it from a JSON format over here, that this target text, there's no mention of datum, and yet the disaggregator classifies this text as both he, him, and datum. So because of the inaccurate categorization or disaggregation by this module, we're going to ignore datum analysis by this model because it's not trained to do so. So let's take a first step at examining data representation bias. We can see in this following cell that the he, him category overwhelmingly represents the data in the Wikipedia bios. And it's not surprising then that a model that's trained on predominantly male data or bias towards he, him will also exhibit more preferential bias towards a particular group. And we can verify this bias by looking at existing pre-trained models like BERT. So here we are loading a model, a BERT model from Hugging Face Transformers library. And we are going to intentionally mask certain tokens. So we are going to ask the model to output us some possible words followed by the previous historical sequence of words. So you will see that It is actually different list of words for both women and men in terms of occupation generated by BERT. In this next section, we're going to turn to another library called Evaluate. Within Evaluate, there are multiple modules that can help us to measure language models from different angles. The first is toxicity, which means how problematic the completion is, such as hate speech. So we'll be looking at that in the following cell. There's a second module called Honest, which evaluates how hurtful the completion is. It works quite similar to what we are seeing above over here as our unmasker. So we're not going to go into it in detail, but if you're curious, go ahead and read this, go ahead and click on this homepage over here, and then you can see that it provides you some easy to start example code for you to apply to your own data set. And the last module over here is called Regard. We'll be looking at this in the lab, so save this for later. So first of all, we're going to load the toxicity module and then attempt to measure toxicity score from the completion. We can arbitrarily define any toxicity value that's over 0.5 as toxic, but this threshold, as I mentioned, is completely arbitrary. You can choose to define a higher value or lower value as toxic. Here, I'm passing in 3 different candidate sentences and ask this toxicity module to evaluate the toxicity score. And we are trying to refrain from typing literal curse words. So you will see that none of these outputs over here actually shoots over 0.5, but we can see that comparing the output toxicity values, indeed, the third sentence over here is the most toxic among the 3 candidate sentences. So this wraps up our discussion about how to evaluate toxicity. In the next section, we're going to use SHAP, which is a game theory approach, to help us to understand why certain words are generated.